Hello, this is Mike Lively from Northern Kentucky University, and today we have yet another one of those really super fun projects, a 3D sync plot in Papervison3D and Flex 3. Now, let me show you the program that we're going to create. And it plots the old sync function, so if you're a physics major like I am, I can remember Dr. Marsh talking about the sine R over R function, and here it is in Papervision. And I've got an amplitude control here. And you can change the amplitude. And you can also change the textures. And here's a real cool one. I put a box texture on here. So it actually looks like those boxes were drawn, but they're not. They're actually just a texture laid onto this mathematical function. Isn't that pretty cool? And there's the wireframes. And you can look at those as well. And this is actually fairly easy to build in Papervision. I'm going to show you how to do it. And we've gotten a lot of help because there's someone out there. His name is Bartek Drosser. And he's got a blog called Everyday Flash. And he's written a program. It's not a plotter program like mine, like plotting a mathematical function, but it plotted a waving flag, like it plotted a waving vertex sheet. Let's go to that website and take a look at it right now. So here we are on Bartek's site, and I have to tell you, I'm really thankful for the work that he's done here, and he's given that to the community, and it really enabled me to create the program that you're going to see today. And he's got basically an animating vertices in Papervision 3, which enables us to create a 3D plotting program, a fairly advanced 3D plot program as well. Let's go and take a look at some of the things he says. Rotating cubes and planes, he's done with that. He wants to try something new. So in Papervision, he's realized that BASIC is composed of triangles, and each object is a structure formed of one or more of them. The points where the triangles meet are called vertices, or plural for vertex, and the vertex represented by the class Vertex3D is basically a point in the 3D space with an x, y, and z coordinate. The interesting part is that each of those vertices can be manipulated separately. And so when he realized that, he was able to come up with this really cool demonstration. Let me play it for you. So we're on the demo site right now of Bartek's, and here's the waving sheet that he's created. Isn't that pretty cool? And you can see as the mouse goes over on to the left side of the screen, the sheet stops going. And as you move in greater x distance of the mouse, you get more vibration of the sheet. If you click on the screen, you get a wire mesh. And click on it again, you have that wavy sheet. So we're actually going to use this code to generate our code. And note, this is Flash, and we're going to change it into Flex. So in this series, we'll show you how to change a Flash project into a Flex project, which primarily is what I deal in. I used to be a Flash fanatic, and then CS3 came along, and all my Flash 8 programs stopped working. And then Flex came along and became mature enough that I went, hey, that is the way to go. It has a more open architecture. I don't feel like I'm as much of a box as I am with Flash, and there's a lot I can do with the coding and with the classes. And there's a lot of, since it's open source, it's free for me, and there's a lot of people releasing a lot of cool code in Flex right now, and so I think it's a very dynamic place to be and program in. So let's go back to the site and start building this. So I'll X this out. And he gives the source code away for free on Google Code. And let's go to that right now. Here's the source code. And all I'm going to do is basically copy this entire package right off of Google Code. And I'm going to paste it into Papervision, and then I'm going to work with it and turn it into a Flex program from a Flash package. Now we're in Flex, and we've created an application file called wavyflag.mxml. And it has the application tags as typical for any new MXML file. And we're just going to paste the entire package of Bartek's code. And let's come along here, and we're going to get rid of the package name at the top. And that means the very last parenthesis has to be, or curly bracket needs to be taken away as well. We notice that none of our import statements are turning blue, which means we have an error. And we just need to put a script tag in there. There we go. And let's take the last part and cut it and put it at the very bottom. And paste it. Now the next thing we need to do is deal with the constructor function. Let's come down here. We no longer need the public class function, so let's get rid of that. Which means we can come down at the bottom and take rid of another curly bracket. And now we'll deal with the constructor function, which is called Perlin Carpet. Let's go ahead and change it to private. And let's put a void statement in there. Doing pretty good here. Now we need to call that, and we're going to call that in the applications tag at the top. So let's go up here, and let's go ahead and put that in here. And you can see we already have it in here. It's called applications complete purling carpet. So when we put a control function there, and we click on that control shift, and we control click, where takes us down to this function, and this function fires. Now there is a basic difference between a Flex and a Flash project, and that's how you add things to the stage. So when the purling carpet function is fired, it fires another function called initiate Papervison3D. Let's go ahead and control and click on that and go to that. And you can see you add this add child viewport. And that's the way you do it in Flash, but not in Flex. Let's get rid of that. And we're going to do this. We're going to go PV3D canvas. That's the name of our canvas. .raw child. So we need to add a canvas name. .raw children. .add child viewport. And that takes care of it for us. But we need to put a canvas in our design mode. So let's go to design. And let's drag a canvas to stage. There we go. And we'll open that up a little bit. Let's go back to source and grab that name. I like to copy and paste a lot when I code. That keeps me from misspelling errors, which I commonly do. There we go. And let's grab that name. Copy that, and we'll go back to design, click on that, go to flex properties, and let's paste that name right in there. And that's the canvas, and that's where it's going to add the child of the viewport, and that's where our 3D objects are going to be displayed. Let's go back to source. Okay, we're making good progress here. There's really not a lot more to do, but a few things we need to take care of. One thing is in the previous program, there was an image being called from the folder, and we've actually got we're in new folders here, and we need to call a different image because we didn't get that image with the source code. So let's do that. So in the purling carpet function, you see there's a mats.push. It's going to push that JPEG into a bitmap. It's going to allow us to switch between bitmaps and wire. And here's my asset folders. And actually, I'm using what's called a color folder. And in that color folders, I have a number of filters. I'll use filter number 3 right here. So we'll call color / filter 3. Okay, now we're getting close. Let's go and run this and see if we get any errors. And you can see we do get an error, one error right here. Let's click on that. It doesn't like the word move, so let's change it. Let's just call it my move. And we're going to come along here to edit. And we're going to find all the moves and change into my move. So let's go to find. Let's call that my move. Find. Then call that my move. And that's all there is. Now let's test our program and see if it runs. And look at that. Lo and behold, it sure does. It's not happy though with that image, so let's see if we made a mistake. And looking back at the bitmap material file, we see I called the file color when it should be called colors. Now let's run the program and see what happens. And there's our bitmap filter, and we have the perfect reproduction of Bartek's Flash program in Flex. And next time we'll move on and turn this into a plotting function.